Immediately.
Thank you, Ian. Can you hear me?
All going
Hello?
well. All going very well.
Great. Thank you very much, Ian, for that introduction. And it's lovely to be here. And I thank everyone for spending some time to this morning to learn a little bit about Azure, to listen to me for maybe about 20 minutes, to have a little bit of Q&A, and maybe to get a little bit of thinking about how Azure, Microsoft Azure, can help you in your research, education, science, and big computing that you might be doing with Azure. So the title on my slide is a little bit different than we have advertised in the webinar, but that's just to give you a little bit of a more perspective on what I do at Microsoft. So let's start by saying hello, introducing myself. So my name is Carl Podesta. I'm Irish, as you might be able to hear from the accent. I'm based in Dublin, Ireland, and I cover Western Europe as a region for Microsoft Azure, and I'm a specialist for high performance computing, or big compute, in Azure. So I work with a lot of companies who are doing supporting science and research in many different fields, but also in education and in research as well. So I'm with Microsoft only about a year, and up to now, and then I've spent my entire career, 15 years, as a Linux engineer, as an open source engineer. I've worked as a consultant. I ran supercomputing at an oil company for 5 years. I supported geoscientists, geophysicists, geochemists. I was in financial services, and I also worked previously in research. So I worked 2 years at a national institute in Ireland, supporting some of my own research into bioinformatics and computing. So in my past, I have been a researcher. I have supported researchers, and that's what I hope to continue to do a little bit at a technical level every day for Microsoft. And I didn't think somebody like me could join Microsoft, being a Linux and an open source person, but that also speaks to the transformation that Microsoft itself has undergone as a company in the last number of years, especially with the advent of Azure and the transformation that cloud computing can really bring to so many people, organizations, but also to scientists and researchers as well. So with that being said, let's get started a little bit with some of what I have to show you. So maybe a little bit of an introduction to Azure for people who might not be familiar. So Azure is the Microsoft cloud. So just to give you a little bit of an idea of the scale of this, this is 42 regions, 150 plus data centers. So multiple data centers in every single of these regions around the world. And the number of regions is growing all of the time. So we are the public cloud that has the largest reach. We're in the most locations in the world, and we want to be close to where our users are, where people are doing their computing. I previously have worked to build a data center. I've been able to visit the Azure data centers in person, and I can say that I don't think in my career I will ever build or support another data center again. The scale and professionalism and security and trust and everything that goes into what we build today in Azure is really so evident and so powerful, and hopefully I can give you a bit more of a sense of that today. So those regions are also supported by 1.6 million miles of interconnected fiber that allow the data centers to talk, data to move freely, to move very quickly, and there are many different ways to be part of that. So many of the institutions, if you're a researcher that you work at, may already be connected through your national network to Azure, and indeed, once you're part of the Azure backbone, even moving data computing between any of these regions is a lot more flexible and freer. And it also allows people to collaborate across countries, across geographic boundaries a lot more easily than previously. So really, you may have even read in the press that we've invested in subsea networks, terrestrial networks, an undersea cable between the US and Africa with Facebook. So these are all things that we're doing to also bring computing closer to where our users are. So ExpressRoute is the name of the network that supports Azure underneath it. So this is really a very high throughput connection, and in a lot of the institutions perhaps that you might work at or that you are working at, this is an excellent way to get connected to Azure. A few aspects of Azure that are so important for us to just talk a little bit about now, in particular trust and control. So when people think of the cloud previously, especially if it's run by a large company, you kind of think, well, if I'm putting my data and my computing in the hands of someone else, can I really trust it? And it speaks to the scale that Microsoft and other public cloud providers have grown to date to be able to have the trust of our users. And it's something that we have first and foremost at Microsoft. There's no way that you would be able to store your data with us, to do any of your computing with us, unless we had your trust. And we go very far to make sure that we try to gain that. So a little bit of an illustration is on the slide at the moment that shows you right from the physical infrastructure in our data centers through the cabling and through the networking and through the computing, right up to the virtual machine and the application level. We have controls in place at each step of the way to make sure that security is foremost, and that includes technical things, of course, like virtual networks, isolated firewalls, security appliances, of course, from different vendors that work with Azure to be able to extend your network out and keep things secure. But also, I suppose, things then up higher on the level, if I scroll across my slide. So right up to I suppose penetration testing that we, even inside Microsoft, do ourselves between different teams that are attacking Azure and defending Azure at any particular time to make sure that we're simulating what's really happening and providing that back. And then up to higher levels in the virtual machine, where you get controls over who can access what at what times, what auditing and logging might be happening on a system, where that's fed back in. And something which I'll show you now called the Azure Security Center, which gives you a little bit of perspective on all of this together. So this is a little bit of a view actually of what the Azure web portal looks like on the right hand side. There's a menu bar down the left and up the top, and we have these panes that move through the right hand side as you go across, called blades, and these give different information. And displaying at the moment is something called the Security Center, and through this we're able to provide information back to you about what's happening in Azure. So not only in your infrastructure that you own in Azure, all of the computing and the resources that you own in Azure, but also the insight that we have from our massive network about what's happening globally in Azure. So maybe information from all of the name servers across the internet. Can we find out if there are particular attacks happening? Can we show that back to you? Or can we even advise that maybe some of your machines may need patching to address a particular security vulnerability? Much of this is addressed and can be done with the tooling that we have in Azure, one of which is the Security Center itself. So one of the other things is that we're one of the most compliant clouds, publicly compliant clouds. So this means that we have, it says 54 compliance offerings on the slide, but I think it's 70 plus at the moment. And this is across global, governmental, industrial and regional certifications that are necessary, that we have gone to make sure we've gotten to, again, gain your trust, gain the trust of all of our customers and our users to know that it's safe in a particular industry, a government, a region, that you can feel safe, that you're compliant when you're keeping your data and you're computing with us. One of the other things, and this is one of my favorite slides in the deck, is that Azure, and indeed Microsoft itself, has changed. So previously Microsoft might not have been associated with being an open organization, or with Microsoft Azure being an open cloud. Azure is an open cloud. So any technologies are welcome on Azure. Open source, Linux, these are first-class citizens. You may have heard our CEO Satya Nadella a number of years ago proclaiming his love for Linux, where we say Microsoft loves Linux. And that's true, because certainly I would not be part of the organization if that were not the case. But really, write down, not only can you keep using your own open source tools and software and your approaches that you prefer to use, and use them on Azure. But internally in Microsoft, things have changed, of course, as well. And even the engineering teams, people who are building tools inside Microsoft, including Azure itself, are often developing in the open on GitHub, publishing source code, interacting with the community, and in particular in the last number of years this has been a real change. So the slide that you're seeing now gives you a little bit of an idea about the ecosystem that we are encouraging, have encouraged, participates on Azure, and maybe as well so important in research and education to use open technologies, to be transparent about the approach and the code and everything that's being used, that can continue if you were to choose Azure to help do some of your computing. So don't throw out any of your tools, don't feel that you have to use closed source software. Please continue to do that and continue to use Azure as the platform that you might do that with. So this is a little bit of a slide from earlier this year that shows some of the organizations, for example, on GitHub, which is a platform for sharing and developing code online, where we're one of the organizations with the most contributors. So this stuff changes all the time, and it depends on contributions, of course, but it's just an illustration of how much as well Microsoft has changed, and how much not just only of the code and the approach, but even the solutions that people use and share with each other is happening currently in the community at the moment. The other thing about it is that we like to make things easy. So something called the Azure Marketplace has a wide number of software solutions provided by our partners, provided by you, to make things easy to use. So particular applications that you might be familiar with using, applications you're developing yourself that you want to make available to others, and even those of our partners. So on-premise tools for doing networking or security. Maybe you want a particular brand of firewall. Even with a single click, this can be available through the Azure Marketplace. So this is makes it also very easy to put solutions together in Azure to do something that you might need. So I'm going to give you a little picture of my piece of Azure. So Azure is as well, just I've given you a little bit of the scale, the size of the scale of the data centers of Azure itself. There are over maybe 150 individual services in Azure: compute, storage, networking, applications, cognitive services, AI, things that have been built. But my little piece is around big computing. It's around high performance computing, which often drives many research and computing challenges. And just to give you a little bit of a sense of how that's currently happening on Azure, how many researchers use that to power and get answers that they need. And this is something that Microsoft has done more of in the last year. So HPC specialists like me have joined Microsoft only even in the last year or two to join others that were part in the previous years to really go bigger with this. So even as a brand where people have heard of big data, well, have they heard of big compute? So really with the scale that we have in Azure, it gives a larger scale of computing capacity available to everyone, really. So it makes high performance computing, previously the domain of supercomputers at dedicated sites, it makes that power available to everyone. So and that includes researchers in all types of organizations, educational, commercial, whatever. You have some science or some problem to do, well, using the power of the cloud to do that is really now a reality. So I'll go a little bit into more about the performance of how that might work, but this is just giving you a sense of what people currently do with HPC on Azure. So they use big calculations for analyzing risk in financial markets. Regulations in financial markets now mean that people need to understand these better, and risk calculations need to be done more, quicker, in particular times, and these can be done at the touch of a button with the power of the cloud. This applies in other domains as well. So I also worked for an oil and gas company previously where we tried to understand things that were happening in the subsurface, beneath the water, beneath the sea, beneath the ground, and using seismic sound waves coming back, understanding that data is a very computationally intensive task, and these are things that some of our customers are currently using Azure to do. Making cars safer, so being able to understand fluid flow, or to crash a car, which might cost a lot of money if you were to do it actually with cars, but if you do it in a simulation, the power of the simulation makes it a lot easier, a lot cheaper. You can change variables, you can tweak things, and when you think then of having an unlimited, relatively unlimited capacity available to you very easily, you can think differently about the types of problems that you need to solve. So this is, of course, in many different domains, and understanding the weather, the climate, and curing diseases. These are examples of how people are using computing to further science. A little bit of what HPC is in particular. It's really an application, some data that we might split across a number of computers acting together. So the computers acting together on a single problem, we'll give it some input, the computers will do their work, and we'll get some output at the end. So there's a very simplified explanation of that, but as you can see on the right hand side, if I scroll across, these are some of the domains in particular that use HPC. And to split that even further, some of those problems might be split into embarrassingly parallel problems or tightly coupled problems. So if you have you want to have a number of machines work together to get your answer, you could easily split that up, wait for them to give their answer, compute their work, and put it all back together at the end. But sometimes the computers need to talk together a lot to exchange information during a simulation, and they need to be very tightly coupled, because if that doesn't happen quickly, the simulation will take longer to do. So this is also where it's people previously have been skeptical that the cloud could perform to do these types of simulations. Low latency networking in the cloud really makes this available and makes this real. So we have the power to do proper HPC now and real in the cloud. So this picture just illustrates something I already said, where previously organizations might have done something like this. They might have crashed a car to physically understand what's happening in the real world, but using the power of simulations, it can just help people tackle different types of scenarios, even think differently about them. So generally, our teams in Microsoft, in Azure, we do have a mission, and in particular for researchers, engineers, scientists, analysts, designers, developers, we want to help help them get better results, faster answers to these problems. So really, it is an interesting tagline to think that if you had 10 times the computing capacity available to you, 100 times the computing capacity available to you, what would you do with that? Would you think differently about your problem? Would you do more problems? So it really unlocks a capability to transform thinking as well for many people. This slide talks a little bit to some of the specifics about our HPC and supercomputing capability in the cloud. So like I talked a little bit about the low latency networking, but we also have specialized hardware. So GPUs are from, for example, NVIDIA, our partner, basically provide a different type of computing capability to think about your problem. And many people are using GPUs to do deep learning and to do different types of computing simulations, or to visualize images that might be happening, and all of those are possible. So the scale that, of course, as a public cloud provider we are at means we have a tight and close partnership with NVIDIA in particular, who provide us with, we have the widest range of many of their cards available to do different types of computing with them, and they become available very quickly in Azure. So also things change very quickly in technology, as you know, and being able to provide the latest technology available and as it comes out is very important, and a benefit of using cloud for solving people's problems. So this slide in particular talks to a little bit about the performance and how it is really real to do these types of scaling problems. So these slides can be available after the webinar, and you can click into this research and learn a little bit more. But this slide that you're looking at was from earlier in the year, and a study that just compared a number of public clouds together, also with an on-premise supercomputer, and found, of course, that Azure came out on top in terms of its ability to scale across a particular problem set and a particular number of nodes. So that helps give people a little bit more confidence that we can do what we say. One of the important things about Azure and Microsoft is that we work not alone. We can't do this alone. We can't bring the power of the cloud to help transform people's problems on our own, and we do this together. In particular for HPC and big compute, again, my little piece of Azure, I suppose. On the slide, you'll see a few of the partners that we work very closely with. So this is right from the operating system level through to the application level, hardware vendors, system integrators, consultants. We need to spread the word about how it is possible to use cloud computing to solve some of your challenges, your problems. In particular, a company called Cycle Computing, which has been doing this actually for the last 10 years, helping people use cloud to do computing. Cycle Computing, we're now very happy to say, are part of our team at Microsoft. So we acquired them, they joined Microsoft, and together we work now using the tools that they have, a tool called Cycle Cloud, small screenshots on the screen there, about how you can think of having almost one cloud for every research group. So even you could give each researcher, or as a researcher, you could have your own HPC cluster, for example, in the cloud, spun up very easily using Cycle Cloud's tools, to really do, instead of sharing a large cluster, for example, at your site and waiting in a queue to get your job done, Cycle Computing almost could give you your own cluster in the cloud to do a particular job, shut things down when it's not being used, and you really get the power to, in terms of costs and optimizations, of course, but also the capability to get your answer right away when you need it. So we're very happy to have Cycle with us. Let me keep going here now with some of these slides. So also to speak a little bit more about some of the aspects in research that we have. So Microsoft Research in particular, we have a division that focuses on research. So we research ourselves, and that probably is to things like quantum computing that you might have heard recently in the press, where Microsoft has committed big to talking more, to doing more with quantum and making it available. But also we support researchers to do their work. So there are also grants available for research to be conducted as well at different times, and also some of the research that we've done ourselves has translated into services. So the Microsoft Genomics service is a new service that we have released in general availability, and actually this takes a piece of a genomics workflow, so where you have genes and you're trying to analyze them to match against a particular disease, for example, to understand a little bit more, to get to a personalized medicine type of approach. You need to process genomes and process large sets of data. So together with the Broad Institute, we optimized some of the common tools, the GATK and BWA software tools for processing genomes has been optimized, and even basically up to 70% even of a decrease in terms of runtime. So I was working with a researcher recently, and it took 3 hours to do this researcher's particular genomics workflow, but using the Microsoft Genomics service, we were able to do this in 40 minutes. So and that was just for one individual for genome. So there's a huge potential as well, especially with some of the cost savings, and this is where we feed that back as well for others to use. A little bit more to the right-hand side then of that slide, there's also something called Azure Notebooks, completely free to use. Search for it now and have a look. So these are very similar to Jupyter notebooks, if you're familiar with those. Many researchers are sharing their research, sharing work that they've done through these notebooks. They're a great educational tool. You can run through them in class. You can see the result of a computation or a calculation or an equation, and they can be shared. So even to supplement a paper that you might be writing, and there's real computing power behind that. So there's a certain amount of computing power actually for free that comes with these Azure notebooks that you can use to drive calculations and help even teaching and education. And one of the other things to mention is, again, to what our new approach, or how the approach has changed to share work in GitHub, and that goes to solutions. So people are sharing, even here is a piece of software that I use to do a particular scientific workflow. Here's a template that you can click on that will make it easy to work in Azure. So the great thing about the cloud as well is that it makes computing and infrastructure available as code. So rather than putting computers together and physically installing software, all of this can be done almost with a single piece of text, a JSON file that describes what the infrastructure looks like in Azure, a number of machines together, some GPUs, some storage, and even after you have done this, even in the Azure portal, if you want, of course, you can run commands and create these machines, but you can also afterwards press a button and you get all of that described in a single text file that can be repeated, that can be shared with others, that can be versioned if you want to change different configurations. So it really gives you a true infrastructure as code mentality, where you can just make computing power available to you very easily. Okay, let's keep going here then. So we're getting, maybe, I have a lot more slides on detail about HPC scenarios, but I really don't want to take up too much time. So just very quickly, these are some of the scenarios in HPC that we talk about. So you can either burst from an existing cluster that you might have on premise to really give you that burst capability in the cloud for particular calculations or times. Of course, with cycle computing, you could stand up an entire cluster, even per researcher, in the cloud, and have that cluster shut down automatically when it isn't being used or when it isn't needed. We also have the capability to do remote workstations. So our NV series, NVIDIA Visualization Series, gives you the power to really see 3D models move in real time, even though they might be running on a GPU in the cloud. And finally, as well, we have a service called Azure Batch. So this is moving up a level. So you don't want to worry about infrastructure and operating systems and applications and everything like that. You just want to write code, you want it to scale, you want it to solve the problem. Azure Batch makes that available to you as what we call a PaaS service, platform as a service. And it really will control all of that for you using whatever compute resources on Azure that you choose. And Azure Batch is free. It's a free layer on top of the computing resources we currently have. So it makes it easier for you to access that. So also, these solutions I'm talking about specifically are only just one building block in Azure. So like I said at the beginning, there's maybe 150 plus individual services in Azure, some of which are listed below. So for example, in networking, in storage, IoT, Internet of Things, where you're pulling information from devices, you might maybe combine them into with something like Stream Analytics to get some more insight on what's happening from that information. Maybe you might use some of our machine learning services to get a little bit better understanding, or our cognitive services, the APIs that might help you to understand more about voice and imaging, and rather than writing your own tools to do that, you can simply avail of ours. And of course, maybe you've got to store the data somewhere, so maybe these things can be used in terms of either Hadoop clusters, HD Insight, Data Factory. All of these things can be put together as building blocks to build a kind of solution that you might need for your problems. So I think I might kind of come to the end of that, and rather than go through the rest of the slides that we have, we'll make this presentation available and people can see more. And of course, contact me. I'm very happy to help anyone through or understand some of our solutions, or put you in touch with colleagues who can also help you do that. So I'm going to skip down a few slides. So there's a little bit more discussion on some of the scenarios, specifically about some of the flavors of computing that you can do in Azure: GPUs, large memory, disks, computing. You can combine these together to do what you need. There's details there on the specifications that we've got, which of course you can find online. We have a little bit more information about cycle computing, so it'll show you a little bit even about where it fits, maybe what the tool looks like, the screenshot you're seeing now, even where you can see jobs submitted to clusters to do computing, and cost control as well on that, but also a nice portal. So if even you're someone who's providing services for researchers at your university, you could give them a nice button to stand up a Redis cluster or a TensorFlow cluster or a Hadoop cluster to do the type of work that they might need, and do it easily, do it controllably as well. a little bit about Azure Batch as well, of course, and this really gives you a bit more information even about how you can use containers to compartmentalize your code, and instead of managing the virtual machines, the operating systems, you can let Azure Batch handle that. You can use containers with Azure Batch if you need, and really you can let Azure Batch control the standing up and shutting down of machines to be able to do the type of computing that you need. This slide shows a little bit of a diagram, which also you can find online, about what it might look like to do that at scale. So this partner of ours stood up 16,000 A1 virtual machines on Azure Batch. The green is when they're open line computing. The red ones have died. Azure Batch will manage bringing those back on. So these can deal with different types of computing workloads. So I'm going to just jump down further a little bit as well to some, at the end of the slides, we also have some stories from customers, other people, what they've done with Azure, other researchers. So you can find these online also at customers.microsoft.com. So you can search for different types of stories and learn more about what people have done with Azure. So the one that you're looking at now is from the University of Victoria, where there's a quote: "Azure basically gives us a solid, rock solid performance, no questions asked, to do some calculations in high energy physics and to cope with the amount of data coming with things like from things and instruments like the particle accelerator at CERN." So in this slide deck, you'll see a few more links to some of these stories in different areas. Customers.microsoft.com again is the place to go for that. So at this point, I think I'll stop the presentation. Thank you for your time if you've listened this far, and open the floor to some questions.
Thanks, Carl. That's been excellent. Remember, people, if you put the questions in the chat window, at the bottom right-hand side of your screens, Carl will be only too happy to answer them. There's an awful lot of stuff in there. I'm sure there's plenty of questions. And I'll upload the slide deck or the PDF onto this window later this afternoon, so if you want to check back, you can have a copy of the PDF with all Carl's slides. So surely there's some questions. You can't have covered everything in that short space, Carl. That's been a lot to take in.
I think it can be, and yeah, so of course most of this information is available online. I think the main thing to communicate also is really that Microsoft itself has changed. We're open, we're sharing things that is happening, and you as researchers, people supporting researchers, can continue to do that. And really Azure is a platform that can help people transform and to collaborate together. And so as these things sink in, people are very welcome to contact me on Twitter or email, of course, as well. So
well, we'll leave the chat box open just for there are. Andres has typed something. There's Stephen's got a question there for you.
Yes, two questions. So Andres's question about our announcement with Cray. Yes, so this we announced this recently, just before the supercomputing event in Denver in the US. Cray, of course, are the supercomputer company. They've made dedicated machines for doing supercomputing for years. So our partnership now means that, and nobody else has this, it's exclusive, that we're working together to really provide high-end supercomputing workloads together with Azure. So for the people and the researchers that use Crays, need Crays, I know particularly in climate research, they're very heavily used. It's possible to use those Crays with Azure. So not existing Crays that people have on site. So this relates to maybe if, for example, you need to buy a new Cray, it's possible to have that connected to Azure in an Azure data center. This can suit also if you have other workloads in Azure, you're part of an organization where there's data moving back and forward. And really, for what we have natively in Azure is only up to a particular scale. And Cray really gives us the ability to address the high-end supercomputing workloads. And we're working together closely to effectively, for the moment, it's like a hosting arrangement, really, where the Cray systems can be hosted together in Azure data centers, closely connected to Azure, and combined with all of the tools even I've discussed to do different types of computing and supercomputing. And then Stephen's question, what options are available to transfer data to and from Azure? So it's a great question. There are many tools available. So of course, from a regular internet connection to a VPN connection, a virtual private connection, to a dedicated connection. The Express Route network I talked about at the beginning provides you a dedicated connection to the Azure data centers. Separate to the physical connections, you can use different software tools to transfer data very quickly. There are accelerated data transfer tools, such as our partners Insigniant, Cognizant, Aspera, File Catalyst. We have our own data transfer tools that can move data very quickly into and out of Azure. And of course, as well, for the really large data sizes, so we have something called the Azure Data Box, which is a physical disks, box of physical disks that can be shipped to you, that can help transfer petabytes, for example, of data back physically to Azure. So a combination of all of those things can help you get your data into Azure and out of Azure. So standard tools, of course, but particularly for these big workloads, lots of data potentially to move in and out, there are various different methods to do that. Important as well, of course, that when these types of workloads often involve computing on the data, maybe you bring the computing to where the data is. So really that is what the NVIDIA, the NV instances unlock. You can have a remote workstation to allow the visualization of your computation, and that can be done on the data. You've created the data, computed the data, gotten the output, it's all in Azure, and then you can visualize the output of that as well. And of course, if you're sharing that with others, colleagues across the world, if it's in Azure, then we have the fastest networks in the world to be able to move that data around.
Well, I think that's a fairly comprehensive answer for Stephen's question there, Carl. Okay, I think that's been a very good value 20 minutes for people to get to know Microsoft Azure and what it can do. So thanks very much indeed. Thanks to all the attendees. I'm going to close the recording now. And as I say, if you check back to the this URL and the website later on this afternoon, I'll have the PDF of Carl's slides there for you to download. And thank you very much for attending. Carl, thank you for your time. Thanks for the presentation. And I wish you all the best. Thank you very much indeed.
Ian, thank you for organising, and thanks everybody for attending. I hope I've helped, and look forward to supporting you in future. Have a lovely day, everybody.